Good morning, students of the BSc second year course. So today we have started the paper number CHE 400 412. That is the name of the paper is Applied Chemistry. So in this paper there are the different units or the chapters we have to go on through. So first chapter, that is we have to deal with, it is infrared spectroscopy, or it is called as IR spectroscopy. Before to start with this chapter, so in this paper, so every chapter deals with all the chemistry related or the analytical or the applied terms or the applied concepts. So we have to study in this paper, that is applied chemistry. So first is infrared spectroscopy. So before to start with this infrared spectroscopy, so I have to first deal with point, that is the introduction. So in introduction we have to see the what is meant by this infrared spectroscopy, how it is works, and it gives how it works, how what are the applications, and what are the drawbacks of this spectroscopy, and what are the applications, what are the instrumentations is used for the completing this IR spectroscopy applications. So this infrared spectroscopy or the IR spectroscopy, it is a powerful analytical technique that identifies molecules by the measuring their absorption of the infrared light, which causes molecular bonds to vibrate at specific frequencies, creating unique fingerprints. Spectrums used to determine the functional groups like the OH, hydroxyl, carbon oxygen, carbon attached oxygen with a double bond, it is called carbonyl, or the carbon attached with the H, that is alkane functional groups, and the overall structures in solid, liquid or the gas samples. It's non-destructive, rapid, and essential in chemistry, forensics, pharmacologies, and material science for identifying unknown substances and analyzing the compositions. So this IR spectroscopy, it is a very powerful technique used to identify the molecules or the organic compounds or the inorganic compounds by the identifications of the presence of the various different functional groups present in our molecule or our material or in the organic compound. So how it works? So it every molecules vibrate at specific frequencies. There is a unique fingerprint region, and this every functional group absorbs this infrared light. So this infrared light is absorbed, and the unique fingerprint region is weakened by this. Every functional group gives a specific bands. So these specific bands, so by the analyzing the specific bands, so we can determine the which functional group is present in our organic compound. So this is how it works. So it works with interactions. Interaction is the infrared light, that is longer wavelength, lower energy than visible light is passed through the sample. So there is a interaction is done between the infrared light and our matter or organic compounds or the any material we have to analyze by using the infrared spectroscopy. Second, absorption. There is absorption is just molecules absorb the specific higher frequencies that match their natural vibrational frequencies, that is stretching and the bending modes. Detections, second term is that is important is detection. An instrument called as infrared spectrometer measures which frequencies are absorbed, producing a higher spectrum. So this detection is done with the spectrometer. This spectrometer detects the frequencies which are the absorbed by our material, and that is absorbed, and this absorption spectrum is plotted according on the basis of absorptions versus the frequency or the wave number. So we get unique spectrum. Each molecule has unique IR spectrum acting like the fingerprint, making it and the excellent for the identification. So this every functional group gives specific unique fingerprint region. By using this fingerprint region, so we can analyze the which functional groups are the present in our organic compound. So if there is a presence of the OH functional group, it gives specific fingerprint region. If there is presence of carbonyl group, it gives specific bands, that is absorption, uh, stretching or the bending vibration bands are the observed. For the carbonyl group, we get specific absorption bands are the observed. If these functional groups are the attached with again a different types of the organic compounds, then it affects the frequencies or the affects the absorption band range. So this all the factors determines these absorption bands are the observed. So this IR spectroscopy is used to detect the functional groups are the present in our organic compounds, and this by using this IR spectroscopy we can analyze the idea, we can identify the functional groups present in our organic compounds. So it's non-destructive, again it is non-destructive and used in the it has various applications, and these applications are the applied on the variety of sectors, that is the forensics in pharmacology, in material science for the identifications of the materials, that is unknown samples, by the analyzing their compositions.